Okay, welcome to lesson 7. This is where we actually start to graph sine and cosine curves with transformations. So we're going to draw two cycles. We're really just going to jump right into it. We've done a lot of transformations in this class before. Sine and cosine, I hope you'll find it are a little bit easier than the transformations we've seen in the past because we have things like period, axis, and amplitude to help us graph, but we will use some of the same language: vertical stretch, horizontal stretch, compression, vertical shift. We're going to use that kind of language just to help us connect. But it really is necessary that you have some understanding of what those are to help you here. But we'll just show step by step. I'm really excited about this lesson because we can really break down step by step how we'd actually do this by hand. So a couple things in the notes, like you'll notice the scale of this graph. We want to make that change. We want to have that nice scale there, and we'll talk about why we're using this scale versus like the 90, 180, 270, 360. This one's actually not even going to go to 360. So it asks us to draw two cycles. We're just going to start by writing the things that we know. And so the first one is the period. The period is 180. The reason why the period is 180 is the base graph starts at 360. This has a horizontal compression factor of 2. So it's this number here traditionally in a function means that the function's been compressed horizontally by a factor of 2. And so the period is going to finish at 180. So instead of going up by 90 every time, we're going to go up by 45. So we're going to compress the 90 by 2 as well. The axis of the curve is 11. The reason why the axis of the curve is 11 is because the plus 11 on the end tells us we've got a vertical shift up 11. So the axis of y equals 0 is actually going to be shifted up 11. And the amplitude is 9. And the reason why the amplitude is 9 is because the base graph, which has an amplitude of 1, is being vertically stretched by a factor of 9. Okay, so what we do is we draw that axis of the curve. This is what the line that we're going to go up and down from. We draw the maximum of the curve. We draw the minimum of the curve. So the maximum is 9 above the axis. Notice the 20 is actually on this line up here, and the 2 is 9 below the axis of 11. Okay. Then we draw our first point. Listen to me very carefully. This is a cosine curve. Cosine curves start at the top and go down. And so that's key there, knowing where to start. Now that you understand that we're going up by 45 every time, then we just have to put points every 45. And the logical place to put it, really, there's only one way because we have to go down. And so we go down to the min, we go back up to the axis, back to the max, down to the axis, down to the min, back to the axis. Okay, so that's our shape. That's it. We're done. We can also go back the other direction as well. So we go negative 45 as well. And we draw our line, and we just draw as smooth as possible through that, and that's our cosine graph. That's our function. Okay. So similarly, we're going to try another one. The period is 120. The reason why the period is 120 is because the regular period of 360 is being horizontally compressed by 3. We're going to go up by 30 instead of 90. That's why we have 30 as our scale here. 30, 60, 90, because the 90 that the quadrants used to be are being horizontally compressed. The axis is y equals -1. There's a vertical shift down to -1, down 1. The amplitude's 3. We do recognize that there is a negative sign here, but we don't have to call that in the amplitude. You can if you want it. It's not really a big deal. But the amplitude is 3. It just means it's a height above the axis. And so there's a vertical stretch by a factor of 3. The reflection will cause us to start on the axis and go down. So we'll see that in a second. So we've got our middle line. we've got our maximum line and we've got our minimum line. And so we've just got 3 below the axis and 3 above the axis. Okay. Put our first point on the middle line because it's a sine curve. But before we do that, we got to recognize that there's a shift to the right 30. Reason why it's a right 30, and in the notes it wasn't right 30, so you change that. The reason why it's right 30 is because of that axis. Just makes it a little bit nicer. Any kind of shift left or right 30, 60, 90 are a little bit nicer to use than if it was just a shift to the right 2, which would just nudge it over. So we draw that line just to recognize that the whole axis has been shifted over. Our first point starts in the middle line. Starts at the middle line because it's a sine curve. And then our second point is actually down from there because it's a vertical reflection. If this negative wasn't up there, we would go just like the sine curve, we would start and go up. But the sine curve starts and goes up, so we're going to reflect it, so we're going to start and go down. The next point's 30 degrees from there, then 30, then 30, then 30, and back the other way, 30 and 30. We'll just draw 2 cycles, and we've got our sine curve. Okay, so similar for each one of them, and that's the best structure. Just take the period, the axis, and the amplitude, and you can just go one step at a time.